Yeah, we started. Yeah.
Hi, Kathryn. Today we're going to record about water.
Yeah. It's
So, the thing is about water is that it looks a little something like this.
Nope.
And because of that, there's lots of electrons up here and not a lot down here. So what that causes is, up here there's a minor negative charge, but down here there's a minor positive charge. And what this does is, in cytoplasm specifically, oftentimes, it splits charged ions. So for example, if you have something like bonded sodium chloride, what water molecules can do is it can come up and break that bond, so you have isolated ions, which are useful for the body. Another purpose of this is that when lots of hydrogens come together, they form H bonds. When lots of water comes together, because the delta positive side of the water is attracted to the delta negative sides of the other bits of water. Each water molecule can form 4 H bonds, and they're usually represented using a dashed line.
Yeah. They provide stability too.
Yeah, lots of H bonds. An individual H bond is relatively weak, but lots of them together are strong.
Yeah.
And what this causes is
Lots of energy required to break them.
is that there's lots of energy required to break them. That causes a lot of cohesion,
Yeah.
which is surface tension,
Yeah.
which is very useful because not only does it provide a habitat for small critters, as well as insulating the water underneath so it's hotter than the surrounding air, it can also allow things such as disobeying gravity, because the H bonds in a plant xylem literally drag up the water inside, which disobeys gravity by going up.
Due to cohesion.
Another use of this is that in practice that leads to water having a very high specific latent heat. And because it has such a high specific latent heat, that makes sweating really useful, because whenever a bit of water out of the body evaporates, it takes a lot more energy with it than if it was something else.
Yep.
Another feature of water is that it has a high specific heat capacity, which makes it incredibly stable, which has two advantages. But the first obvious one is that it makes aquatic environments very stable temperaturally, so they're usually hotter than the surrounding environment, which allows more space for wildlife.
Yeah.
But also inside of cells, it's very stable to have water because it keeps enzymes in optimal condition for obviously their purpose. It creates a stable environment. I don't know how we intended to link this, but ice is less dense than water, because liquid water is often clumped together, but ice forms hexagonal shapes, which is not dense.
This air in the middle.
So what that does is it flows to the surface, creating a layer of ice. Underneath is nice warm water because this is insulated from the cold air.
Yeah.
And above there's also an environment for creatures such as polar bears. That's not a polar bear. I don't know what I just drew. But so yeah.
Yeah.
Cool.
Water.
Water.
Bye bye, Kathryn.